Solving systems of equations using substitution. Substitution means that we will take what we know from one equation and place it into a second equation to solve the equations for the missing variables. If you're going to solve a systems of equations, you need to have one equation for each variable. So for example, here I have an x and a y. That means I need two separate equations. So for this one, our first equation is 3x minus 2y equals negative 7. The second equation, let's say that we're given y equals 2x plus 6. I have two unknowns. I have x and I have y. And I have two equations. That means I can solve for x and y using these two equations. 3x minus 2y. There's a lot going on there with the x and the y. But look at this one. In our second equation, we're told y equals. Y is already solved and by itself. We can use that information and replace this y to solve the equations. So, if we rewrite our first equation, we have 3x minus 2. Instead of the y, let's put a parenthesis. In that parenthesis, we're going to put what we know y is equal to. In this case, we're told y equals 2x plus 6. Now we can solve. The first step to solving is to do our distribution of the negative 2 from right here. So we have 3x minus 4x minus 12 equals negative 7. Then we can keep going. Let's clean this up. 3x minus 4x is negative 1x. If we add 12 to both sides, divide both sides by negative 1, we found that x equals negative 5. Well, x equals negative 5 is great and all, but we haven't found the solution yet because we don't know the y coordinate. So far, we've found out that x is negative 5. We still need to figure out the y coordinate. You have two equations here. It does not matter which one you use. If we're solving the systems of equations, we're looking for where the two equations intersect. So if you use this x value in either of these equations, you'll get the same answer for y. This one's already solved for y equals, so I'll just use that one. We think that x is negative 5, so we should put a negative 5 in the parenthesis where the x was. So rewrite where the x is, put a parenthesis, and put our x value in that parenthesis. 2 times negative 5 is negative 10. Negative 10 plus 6 is negative 4. So that means that y equals negative 4. It's always a good idea to check. To check a systems of equations, you use the equation that you did not use for the second variable as your check. So for example, we used y equals 2x plus 6 to solve for the second variable to solve for y. So that means we should use this equation for our check. So we have 3x minus 2y equals 7. We think x is negative 5. So let's do our parenthesis, and in that parenthesis, let's put the negative 5. We think y is negative 4. 3 times negative 5 is negative 15. 2, I forgot the negative, there we go. Negative 2 times negative 4 is positive 8. Negative 15 plus 8 is negative 7. That works. So that means our solution of 5, negative 4 is correct. Let's try again. Number 2. We have x minus 0.5 y equals 1.7. And we have 10x minus y equaling 1. Well, what should we do here? I don't like these decimals, but I see a times 10 right here. So maybe if I put those in, I could get rid of those decimals. So let's try that. Let's solve this first equation here for x, and then we can substitute it in here. So that means if we solve this for x, we need to move that 0.5y to the other side, and we'll do that by adding. So x equals 0.5y plus 1.7. Well, I have x equals right here, so let's rewrite that bottom equation, but leave a parenthesis where we see the x. And in that parenthesis, we can put what we're told x is equal to. Now the good news is when we distribute this, we get rid of our decimal, and we're left with 5y plus 17 minus y equaling 1. 5y minus y gives us 4y. Subtract the 17 from both sides. Divide both sides by 4. And it looks like y is negative 4. Now we need to figure out what x is going to be. We can use any of these equations. It's recommended not to use the one that you solve for, because if you make a mistake, you won't catch it if you keep using that. So I always like to go back to the original. I think I'll use this one. So we have 10x minus, put a parenthesis. Inside that parenthesis, we put what we think y should be, which is negative 4. So that gives us 10x plus 4 equals 1. Subtract 4 from both sides. Divide. There we go. So let's check it. We think that our solution should be negative 3/10 negative 4. Let's check it. I used this one to solve for the x value. So that means I should check it in this one. I'll put the check right here in the middle. So we have x. We think x should be negative 3/10 minus 0.5 times y, which is negative 4, equaling 1.7. Well, everything else is in decimals, so how about we put this into a decimal as well? That's going to be negative 0.3. If I distribute right here, a negative times a positive, a negative times a negative is a positive, and 0.5 times 4 is 2. Negative 0.3 plus 2 is 1.7. That works. So that means our solution of negative 3/10, negative 4 is good. Let's try again. Number 3. 2x minus y equals 6, and y equals 5x. Well, we have this one solved for y, so let's go ahead and use that, and we can substitute it in for the y right here. So we'll rewrite 2x minus, where we had the y, we'll put a parenthesis, and let's put in what we have y equal to. So now we have 2x minus 5x. Well, 2 minus 5 is negative 3. Bring the x. Divide both sides by negative 3. So we have x equaling negative 2. Now we need to solve for y. This one already has y equals, so I'll use that. So rewrite, put a parenthesis. In that parenthesis, put what x is equal to. 5 times 2 is 10. A negative times a positive is a negative. Now we need to check it. I used this one to solve for y, so let's use this one to do our check. Leave a parenthesis for the x. Leave a parenthesis for the y. And fill in the values for x and y. So x was negative 2, y was negative 10. 2 times negative 2 is negative 4. Negative times a negative is a positive. Negative 4 plus 10 is 6. That works.